वही आना है ना। Yes, good morning to all. See, I am taking that is Unit 4. Unit 4. Applications. Applications 2 of multiple integrals. Multiple integrals. So first one is double integration. So that is in that, so plane area. So already madam, she has completed how to evaluate the double integration. So when the limits are given, when the region is given, so and now that is I am taking. So how to find out that is area of the particular region. Suppose if it is given to you, if this is y dash, suppose one parabola is given to you and that is another line is given. So in this place you can see that suppose if you want to find out that is area under this region. So it means what, two lines and one curve, or so that is goes to area of this region. Here also these two lines and one curve. Some region of integration will be given to you. How to find out that is area by using the help of the double integration. In PUC you are completed how to find out that is the area by using a line integration. Because of either this region you take it or this region you take it, that is suppose if I taken AOB or that is goes to B, this region AOAB or this region OAB, you can take it. So here that is goes to, will go along with the border, that is C1, here it is goes to C2, here it is goes to C3 for the below region. Similarly OA, AB and BO. So this is for this region, means what? Using the help of the line integration, that is called single integration, will go along with the border of the region. Now the same area, how to get it by using the help of the double integration. So in the evaluation of the double integration, you have taken that is goes to region R or A or domain B, it was given to you. So here f of xy into that is goes to dA, dr, or so that is dx, dy. Out of the three, any one notation will be there. Evaluation of this double integration, when limits are given, how to evaluate? When the region of integration is given by taking the horizontal or vertical strip, how to evaluate it? Means what, you have to find out the limits of integration from the given region. Or the third, that is the third one you have taken, that the change of order of integration. Sometimes, so we'll change the order. It means what, if the horizontal is given to you, you will change it as vertical, or if vertical is given to you, horizontal. So the next one you have taken the evaluation of the double integration by using the help of change of variables. That itself you are studied as in the double integration in this semester, that is changing into polar coordinates. Okay. Now here that is goes to the plane area, what it is there, that is region remains as it is, the functional value changes. So what is the formula to evaluate it? That is the plane areas. So using the double integration, in the double integral, if the functional relation what is given to you inside the integration, it should be equal to 1, then so plane area is given by Okay. So that is capital A is the area I am taking, that this is comes as region R. So dr, or it may be given to you dx dy, or it may be given to you dy dx. It means what? That is evaluation of the double integration, some functional relation will be present inside the integration, that is called some region will be present. Surface means what? That is goes to some figure will be present now. So some relation will be given to you. If this relation is equal to 1, if you are taken, what the double integration evaluated you are taken, that itself is gives the plane area. So sometimes that is goes to if region is, if the region is bounded by polar curve, that is curve, then so plane area what it is there, we can write double integration over r dr d theta, because of in the change of variable you are taken that x changes to r cos theta, y changes to r sin theta, and one more is dx dy equal to mod of Jacobian into dr d theta. With proof you are taken in the change of variables. What the Jacobian transformation for these two variables, Cartesian to polar, are there, that itself is gives to us as r notation. The same thing I have written is here. So now that is, these are the two formulas are using to evaluate it, that is the plane area bounded by some particular region. So in PUC you are completed area bounded between the two parabolas by using the line integration, that is called single integration. The same example presently I will take it to find out the area by using double integration. So first example, find the area bounded between the parabolas y square is equal to 4ax and x square is equal to 4ay. Okay. Only if this term is given to you, you have to use it the double integration. Sometimes using, that is by using, they will print it very clearly by using double integration. Okay. Solution of this example. So given data is two parabolas are there, y square is equal to 4ax and second one is x square is equal to 4ay. These are the two parabolas are given. First you draw the rough figure for these curves, or that is the straight line, or what it is given to you. So y square is equal to 4ax, it is a parabola symmetrical about x-axis. Okay, and x square is equal to 4ay, it is a parabola symmetrical about y-axis. Both the parabolas are intersecting at two different points. One is O and the second origin, the second one is goes to assume that A. So now that is using the help of these curves equations, either two curves are there, two lines are there, what the equations are given to you, solve these two equations to get it the point of intersections. So that is, I'll write it as solve 1 and 2. So I'm substituting from 1, x is goes to y square divided by 4a, or somebody will think it as from second equation, y is goes to x square divided by 4a. So what the value of x is there, that is substituted from the first equation I have taken. Now this value should be substituted in the second equation. So 2 becomes, so this is y square divided by 4a whole square is equal to 4ay. RHS side I have kept as it is x square. In place of x, what it is you are evaluated, that much I have substituted. This is comes y raised to 4 divided by 16a square is equal to 4ay. Or this is gives us as y in bracket y cube minus of that is 64a cube is equal to 0. This term I have shifted to that side and take it the common term. So this implies one is y equal to 0, second one is goes to y cube is equal to 4a whole cube. that itself is goes to 64a cube only. So one is gives us as y equal to 0 or y equal to 4a. It means what? That is, when you are solving these two equations, we are having two different values of y. For these values of y, what are the corresponding value of x are there? You have to evaluate it by using these two equations. When y equal to 0, either you substitute it here or you substitute it here. From both the equations, you should have the same value for, that is, another variable, that is, in this example is goes to x. When y is 0, x is 0. That itself is called one point of intersection is the origin. And the second one is, when y equal to 4a, either you substitute it in this equation or that equation. In both the cases, you will get it the same answer. Here, if you are substituted, that is comes as 16a square divided by 4a, that itself is goes to again 4a only. Or if this term you are substituted, you will get it 16a square. That is, x square is equal to 16a square, or x is equal to plus or minus 4a. Minus 4a we are not using because of this point of intersection is in the first quadrant. So 4a comma 4a. So whenever that is rough figure, you will take it, that is corners, you have to evaluate it. The coordinates of the corners of each and every point of intersection, you have to evaluate it. Here only two are there, both I evaluated. Suppose if three are there, so all the 3 point of contacts which are there, that is those terms you have to evaluate by solving the, that is given equations. Once that is, if you will evaluate it, after that you have to decide it, means or just it is evaluation is where evaluation is nothing but you have to find out the limits of integration. So here, so we are having two methods. One is goes to integrate along the horizontal strip. So, or integrate along the vertical strip. If you are decided to horizontal strip is nothing but you are decided to integrate first with respect to x, keeping y as constant, then with respect to y. Suppose if you are taken, that is goes to vertical, means you are integrating with respect to y first. Vertical is nothing but that strip will be parallel to y axis, and you are decided to integrate first with respect to y, keeping x as constant. Now presently, so both at a time don't take it, only one you have to take. Now presently I have taken that is horizontal strip. By mistake, if you are changing the same example, vertical strip also, answer never changes. Here that is goes to integrate along the horizontal strip. So notation wise I have taken that, so PQ. Okay. Now, so that is for which horizontal means what? X varies from where to where. Geometrically I can say that P to Q. P is a point which is lie on the curve, or it may be lie on the straight line, what it is given to you, and for this P is a point which is lie on. So y square is equal to 4ax, the parabola, and Q is a point which is lie on x square is equal to 4ay. Now from that is, since P is a point on the parabola, y square is equal to 4ax, therefore that is goes to lower limit for x is goes to y square divided by 4a. From this curve equation, this line equation, x should be converted in terms of y, or it may be constant. And in this example, since it is a curve, you are having that is goes to variable. Suppose if it is y axis is there started, that is comes as x is equal to 0. Now up to q, so here x square is equal to 4a by, or x is equal to plus or minus 2 times root of a by, minus need not to take, that is because of, so it is in first quadrant. Means when you take it the horizontal strip, x goes as a function of y, but never comes both are in terms of constant. The one limit may be constant, one may be variable, but both never will be, that is constant. Constant limits only comes when the region is a rectangle or a square. Otherwise, so you will be having either of one limit, at least either of one limit should be a function of the other variable. And so y varies from where to where. So always whenever you will take it the horizontal, x starts from left side, ends with right side, and y is below, and that is goes to y is below to above. Similarly, So now here that is goes to y limit, what it is there, lower point, that is lower limit, up to the upper limit, what it is there, 0, and here it is goes to 4a. So 0 to 4a. Either this example you are solving or any different example you are solving, whenever the Cartesian, that is curve, is given to you or equations are given to you, this is the only procedure you are going to apply. Only the change, sometimes what happens, in place of horizontal we'll take it as vertical, or in place of vertical sometimes we'll take it horizontal. But which one you need, you can take it by thinking. Okay. So here, since both are these parabolas are there, either of one you take it randomly, nothing will happen. So sometimes parabola and straight lines are there at that time. So little bit carefully you have to take. One example, we'll see that later on. So now here that is goes to, therefore, area A equal to, now double integration over R, that is goes to dr, or it is A dA, you can think it. Now already you are decided that is goes to horizontal strip. Horizontal strip is nothing but dx first, dy second, means what you are decided to integrate first with respect to x. Suppose if vertically p are taken, in place of dx dy you are writing d by dx. Limits are calculated, that is goes to 0 to 4a, and here it is y square by 4a to 2 times root of ay. So first you have to integrate with respect to x, keeping y constant between what the limits are written. So then that is you have to integrate with respect to, that is y. So here that is, this is equal to 0 to 4a and dy as it is. Integration of dx is x, limits of integration is y square by 4a to 2 root of a by. Or this is equal to 0 to 4a 2 times root of a by minus of y square divided by 4a into dy. Upper limit minus of lower limit. Now this is equal to 2 times root of a. Root y integration is goes to y raised to 3 by 2 upon 3 by 2. So minus of 1 divided by 4a as it is here, y cube divided by 3. Limits of integration is 0 to 4a. So this is 4 by 3 into a raised to half. Root a is nothing but a raised to half I written. 2 goes numerator, 4 by 3 I written, and here it is upper limit a raised to 3 by 2 minus of 1 divided by 12a 4a whole cube. Or all together this is 4 by 3. Here bases are same, powers must be added, it is comes a square, and here that is comes as 16 by 3 a square because of 64 divided by 12. Or this term comes as not 16, most probably. One minute, that is 2 root a by . So right, it is correct. Okay, that is just simplification, you have to do it little bit carefully. 4 by 3, this is comes as a square, here it is 16, it is not 16 because of 12 as it is 4 cube, 64 a cube, here it is a, 4 by 3 a square minus of this is 4 3s are 4 1s are 16, that is 16a square by 3, and here it is goes to something doubt is there. Answer is 16a square by 3. Dx dy, that is goes to upper limit is correct, lower limit is correct. Raised to 3 by 2, this is raised to 3 by 2, 4a cube, 4 cube. Yeah, everything is correct. So y raised to half integration is y raised to high by 3 divided by 1 by 3. This is equals to y raised to 3 by 2 upon 3 by 2. Yes, it is correct. Minus of 12a square by 3. Doubt is there. Just a moment, we'll think it. 1 minute. This is y squared by 4a. Yes, this is 2 root of a by, this is 0 to 4a. By mistake, if you will get area is non-negative, this is we can write, but the answer I remember 16a square by 3. So once you check it, that is goes to any simplification mistake is there or not there. Otherwise, one more time I'll solve it. Okay. A square is correct here also. Yeah, most probably somewhere I am doing the simplification mistake. Answer is goes to 16a square divided by 3. Yeah, it is a PUC example. Not solved. That is, they are given or not given. We'll see that. Area between parabolas. Answer is sure 16a square by 3. This is the correct answer. Once you check it, the simplification. 3 is the LCM 12. Yes. Here any mistake. Y square by 4a. Root a, this is correct, this is correct. 12a y cube. Yeah, answer is 100%. That is goes to 16a square by 3. What the mistake we are doing, you check it one more time. If not, that is goes to contact me by message. Okay. Second example, we'll take it. That is, find the area of the cardioid are equal to a in bracket 1 plus of cos theta. There are 4 cardioids are there in the polar fashion, 1 minus cos theta, 1 plus cos theta, 1 plus or minus sin theta. So out of the 4, anything you can take it, the process remains as it is. So only the difference is limits, or it may be the figure. So now that is given curve I have taken 4 by 3. Yes, answer for this example surely that is 16a square by 3. We'll check it one more time. So here that is goes to now cardioid. How to draw it this figure? Whenever the equation of the polar curve is given to you, which is connected with cosine theta or sec theta, So that is goes to that curve will be symmetrical about that is initial line. It means what the above the x-axis is there, the same figure comes below the x-axis. So now second one, this is the pole, this is x-axis, this is x dash and this is y dash. Either the curve passes through the origin or not, it is completely depending on the value of r. For any value of theta, if the corresponding value of r is 0, corresponding value of r is 0, then the curve is passes through the pole, otherwise no. So here when theta equal to 180 degree, so here cos of 180 degree is -1, minus of plus 1 is 0. So therefore the curve is passes through 180 degree is nothing but this is called theta equal to pi, this is called theta equal to 0. This is called theta equal to 90 degree, this line is called theta equal to that is 3 pi by 2, 270 degree. And at the same moment, again you'll come back to the same 360 degree and 0 degree, both are coincident. Means what? The same axis you will get it as x-axis. So at 180, this is 0 is nothing but the pole. Okay. So now you can see that in this example, as theta varies from 0 to, that is goes to anti-clockwise direction up to 180 degree. What the changes takes place in the value of r, so that much you have to take. So here that is when theta equal to 0, you are having 2a. So 2a is nothing but I don't know what is a. If I had taken a equal to 1, approximately that is 2. Now when theta equal to increasing, assume that that is 30 degree. Cos of 30 degrees, what the answer comes, that much you have to simplify. So it means what? Less than 2a only comes, it is decreasing. Up to here it comes, you can see that. Now when it is 90 degree, here you will get it as a, that is only 1 you will get it, half. Okay. So when it is 120 degree, 120 degree is nothing but minus half, a by 2. Its length what it is there, half, but and that is goes to, angle is goes to 120 degree. If it is 180 degree, it is comes as 0. It means here it is comes in this format. And what the above is there, the same thing you have to draw it in below also. Means what? Cardioid will be the heart-shaped figure. So this is what above the x-axis is there, the same term, same figure will be present below the x-axis. Try to draw it properly. Now, somebody will think it about I want to take it the complete region of integration. Somebody will think it about I want to take symmetry property. So suppose if you are needed, that is since the curve is symmetrical about the initial line, therefore 2 times above the initial line, what the figure is there, what the region is there, the same thing is present here. So by the symmetry, required area, RA I am writing 2 times, that is 2 into area above the initial line, above the initial line. Okay. So now that is goes to here, theta varies from where to where and r varies from where to where. Varies from. So minimum angle is goes to positive direction of x-axis, that is called initial line. Its angle is goes to 0 degree. It moves up to, that is goes to negative direction of x-axis, is nothing but 0 to 180 degree. And so r varies from where to where. So that is goes to, it is depending on either the polar curve is passing through the origin or not. If it is passes through the origin, then from the origin you have to draw the line. Means minimum radius is goes to 0, the maximum radius is goes to up to here. Either you take here or you take it here. Anywhere the point you can take it on the curve, its equation remains as it is. Means what? R varies from here to up to the circumference of the curve, that is called 1 plus of cos theta. R varies from 0 to a in bracket 1 plus of cos theta. Suppose if it is the curve is not passes through the origin, sometimes you will get it 1 circle, 1 cardioid. So from circle, outside the circle, inside the cardioid, or outside the cardioid, inside the circle, how they will give it to you according to that one. If the part is not passes through the origin, so from inside curve to outside curve, draw the line, and which that curve, inside curve to outside curve will be the limits of integration. So now that is therefore, required area equal to, so 2 times area, that is polar curve r dr d theta. So theta varies from 0 to pi, r varies from, that is 0 to a in bracket 1 plus of cos theta. Okay, first you have to integrate with respect to r, keeping theta constant between the limits which is given 0 to a in bracket what it is there. This is equal to 2 times 0 to pi as it is, this is d theta. Now r integration is r square divided by 2. Limits of integration 0 to a in bracket 1 plus of cos theta. Okay. This is equal to, this 2 and this 2 cancels, 0 to pi. This is comes a square in bracket 1 plus of cos theta whole square into d theta. Yeah, after this step only there are so many methods are there. Somebody will think it a plus b whole square, a square plus 2ab plus b square. Someone will think it that is I want to use it half angle formula. 1 plus of cos theta is goes to, so 2 cos square theta by 2. Limits of that is goes to, this is whole square into d theta. Not at integrated, just one formula I have used, 1 plus cos theta is 2 cos square theta divided by 2. So this is equal to 2 square is 4a square. Now here 0 to pi, this is cos raised to 4 theta divided by 2 into d theta. So, and in integral calculus at the beginning only it was given to you, that is reduction formulas. When the power of cosine or sine trigonometric function is more than 3 are there, even though 3 or 2 are there, we can use it very easily by using the help of the reduction formula. But the condition was given there, that is goes to 0 to pi by 2. Okay. Either cos square, that is cos raised to nx into dx you are taken, or sine raised to nx into dx you are taken. But the limits of integration has to be compulsory, 0 to pi by 2, but it is not there. At the same time, here it is theta by 2 is there, means what, half angle formula is there, so that much substitution method we can solve. So put theta divided by 2 equal to any other notation you can take it other than theta, or d theta is goes to 2 times dx, or here it is theta is goes to, so 2x. That itself is d theta is goes to 2x. Whenever the variable changes, limits of integration may be changes. Also, when theta is 0, what about ex? When theta is pi, what about ex? That much you have to evaluate it. When theta is 0, 0 by 2 is x is 0 only. When theta is pi, x is goes to pi divided by 2. Or this is comes as 4a square, 0 to pi by 2. So cos raised to 4th x into, that is 2 times dx. So what are the substitutions are there? Those terms should be substituted in this place. Or 8a square, 0 to pi by 2, cos raised to 4x into dx. Now this is constant outside. So remember those formulas which are given to you. Cos raised to nx, sin raised to nx, and product of sin and cos. Out of the 3, any one, so can be, that is goes to, which is applicable to particular example, so that much you have to use. Either the number what it is present, it may be even or it may be odd. Whatever may be, the process remains as it is. That number minus of 1, that number minus of 3, odd numbers should be subtracted in the index. So up to what factor you have to take, stop before getting 0 or negative. Means what, next factor will be 4 minus of 5, that comes as minus 1. You have to stop before getting 0 or negative number. Divided by, how many factors are there? The same number of factors. Means what, if 3 are there, 3 factors. If 100 are there, 100 factors. I have not used the word same factors. Same number of factors I have used. Now here that is goes to what the index is there, index minus of even number. If it is 10 is there, 10 minus 1, 10 minus 3, 10 minus of 5, 10 minus of 7, 10 minus of 9. So, and its next factor is goes to 10 minus of 11, which is negative, means stop before getting, so that is 0 or negative. How many factors are there in the numerator? The same number of factors will be remaining in the denominator. So, into, that is goes to, what are the possibilities are there? Single trigonometric function, if the even power is there, either 4 is there, so 6 is there, or 100 is there, extra comes, that is goes to pi by 2. So, in the regular class it is given to you. If it is odd number is there, so same thing, that is just it is 1, no pi by 2, nothing will be multiplied, extra multiplication is goes to 1. So, all together will simplify, these two terms cancels, balance is 3 pi a square divided by 2, this is the answer. Suppose, if you are having 1 minus cos theta, the same figure comes reverse. Limits what it is, the symmetric property 0 to, so pi only it remains. Means depending on the region, that is goes to symmetry, you have to adjust it above the x-axis or left or right of y-axis, how it is convenient for you. So that much you have to adjust it. If you are unable to adjust it, symmetric property, so don't do anything. So don't use it the symmetry to remove, then entire region you have to consider. So theta varies from start with initial line, so go up to here, continuously come back to up to this place. So at that time that is goes to 0 to 2 pi, r remains 0 to the same thing. 2 don't want, that 2 comes in this place because of complete region you are taking, that is 360 degree. Simplify, you will get the same answer. Yeah, this is the example where we have done mistake, I am not getting it. One more time I will solve it this example, that is better. Otherwise, so I will make a video, just I will send it the answer for you. Cylinder common. Find the area of the ellipse they have told. So third example, find area of the ellipse, area of the ellipse using ellipse equation may be given or may not be given. So this is y square by b square is equal to 1. Okay, this is called, in PUC we are studied as a conic section ellipse by using double integration. By using double integration. If it is not given by using double integration, try to use it double integration, because of double integration will be more easier than single integration, that is called line integration. Okay. So solution of this example, I will write it as given. A square y square divided by b square is equal to 1. I will take it as equation number 1. Okay. Now, so draw the figure. Ellipse, everybody you know that. Major axis, minor axis, what it is you are taking. So this is x dash axis, y dash axis. These are the 4 points of intersection. A dash, B dash, minor axis you are taken. Okay. Since the ellipse is, this figure is symmetrical about both the axes. What above is there, the same thing is below. What the left side is there, the same thing is there, right side. Therefore, by the symmetry I can say that total area is equal to 4 times area in the first quadrant. Whatever maybe it is there in the first quadrant, that should be multiplied by 4. That gives the total area of the ellipse. Now, by symmetry, RA equal to, that is called required area equal to 4 times, that is called 4 into area in the first quadrant. Area in the first quadrant. Okay. So for which means what you are using the symmetry, integrate along the vertical strip. Because first example I was taken horizontal strip, now this example I am changing into vertical. Here also you are free to take it, that is horizontal only. Vertical strip PQ. Okay. Which is you are decided, you take it vertical or horizontal, you give the symbol same thing, that is goes to PQ. So whenever vertical, if you are taken, P comes as a lower limit and Q comes as an upper limit. So for which y varies from, because of since it is vertical strip is there, first you have to find out y as a function of x, and x will be always in terms of constant. Y varies from where to where. So geometrically I can say that P to Q. P is a point which is lie on the x-axis. X-axis equation of the x-axis is goes to y equal to 0. Lower limit for y is goes to y equal to 0. And upper limit is goes to Q. So Q is a point which is lie on the ellipse, circumference of the ellipse, what it is there, this equation. From this equation, you have to find out y as a function of x. Just a moment, you see that what it is comes. That is 1 minus of x square divided by a square. This x square upon a square, you shift it to that side. B square, you take it that side. Okay. So it means what? This is outside b square comes. But we have needed y, not y square, we have needed y. So plus or minus comes, but need not to apply plus or minus. So directly you can write it, the answer is b into root of this much. Or this itself somebody will write b divided by a under root a square minus of x square. Means what? That is given equation, you transfer y in terms of x and get the values of y. You will be having two values plus or minus. Since it is in the first quadrant only, I have taken the upper limit is goes to positive. And x varies from where to where? Left side is goes to this point. This line is nothing but x is equal to 0. This another end point is goes to this one. This point gives the coordinates of end point, that is called a comma 0. So that is goes to 0 to up to x coordinate of this point a is there. So take it in the required area. Required area equal to 4 times double integration. You have taken vertical, that is dy dx. What are the limits are there? X varies from 0 to a, y varies from b divided by a under root a square minus of x square. Integrate it. 4 times 0 to a, this is y. 0 to b divided by a to root of a square minus x square into dx. This is equal to 4 times 0 to a, b divided by a under root a square minus x square, lower limit need not to substitute because of 0. So constant number remove outside and the rest part you integrate it. This is equal to 4b by a. 4b by a. Integration of this term by using the PUC formula, what it is there I am writing. X into root of, or you are taken x by 2 root of a square minus x square plus of a square by 2 sine inverse of x divided by a. Limits of integration is 0 to a. 0 to a. Now, this is equal to 4b divided by a. When you substitute it, the upper limit a square minus a square is 0. When you substitute it, lower limit x is equal to 0. Therefore, need not to substitute. Whenever both upper and lower limit after the substitution, if you are getting 0, need not to substitute, directly write it, it tends to 0. And this constant number a square by 2 as it is. Only sine inverse you have to write. Sine inverse of 1, lower limit sine inverse of 0. This is comes, so 2ab. So simplified answer is goes to 2ab. And here it is comes as pi by 2 minus of 0. I hope it is comes as pi ab. And area of the ellipse you have studied already, that is comes in the form of, that is pi ab only. Okay. Yes, here you will be having so many questions connected with the area. Okay. And most of the examples which are solved, that is notes is given to you, refer that notes. And any doubts are there, you without hesitating, you call or that is send a message through WhatsApp to me. Okay. Yeah, still 1 minute. Time is there. One more or two more examples, if possible, will solve what they have given. Okay. Yeah, two more are there. That is, I'll solve. Find the area by double integral. Double integration. Okay, between the parabola and the line. Line is given is y equal to x. Okay. One parabola, one line. Yeah, don't remember the particular example. Either parabola, line is there, two parabola is there, cardioid is there, circle is there, ellipse is there. So only remember, sorry, parabola equation only I have not written. Parabola y square is equal to 4ax minus of, what they have given, 4x minus of x square. Y equal to 4x minus of x square. Okay. Now in this example, given data first I will write. That is, y equal to 4x minus of x square, first equation, y equal to x is the second equation. This is not a problem because of it is a straight line. Okay. Now this is the parabola. Suddenly everybody will not be able to tell what is the figure for this equation. So because of only two parabola, standard form of parabolas you have studied, one is y square is equal to 4ax and x square is equal to 4ay. Okay. Now, so you have taken that x square is equal to 4ay, one term, or one more you have taken x minus of h whole square is equal to 4a in bracket y minus of k. That is correct. Means what that is goes to, vertex of the parabola is goes to at the origin. But the vertex of the parabola is h comma k. That is, vertex of the parabola is shifted to the new origin without changing the directions of the axis. Axis of the parabola is goes to x-axis, y-axis or x-axis, what it is there. So now that is goes to this. What is the figure? Here it is there. You can see that. So this term, vertex of the parabola is the origin. Axis is goes to y-axis. Now in this example, without changing the direction, we are getting the new parabola. What it is there, you can see that. This is x-axis, y-axis. What you have studied in PUC, the same thing I am taking. Here this is called y dash. Here it is called one more x dash. This is called new origin. Shift the origin O to new origin O dash without changing the directions of the axis is nothing but this is the parabola which is having h comma k is the vertex. Okay. Means since it is both are there, therefore I am adjusting in that way. Now in this example, what it is there, you have to see that this term x square minus of 4x is equal to minus y. These two terms I have taken this side, y I have taken this side. This is comes x minus of 2 whole square. Its expansion, what it is gives to you, you have to see that term. So a minus of b whole square, a square minus of 2ab plus of b square plus 4 you are getting extra. So that side also you add it plus 4. Agree? Means what, the entire simplification should be back to the original equation, or x minus of 2 whole square is equal to minus of y minus of 4. Means this equation and this equation almost same, opposite in sign. There you are taken one more parabola is minus. When it is minus, it comes below. When it is that is minus, this comes below. So therefore the parabola is having the vertex is 2, 4. Okay, and axis of the parabola is goes to negative direction of y-axis is there. So rough figure I am taking here. Think it, that is one term. X-axis origin, y-axis 2, 4. If this distance is, if you are taken 2, then this distance is approximately 4 because of x coordinate is 2 and y coordinate is 4. So approximately this point I have taken, and this parabola is passes through the origin because of at x is equal to 0, y equal to 0, will get it. LHS and RHS are same, means that is this side. Okay, now here this is comes y dash axis, this is new vertex, what it is there. Now, one parabola is completed, the line what it is there, you have to see that. So this line I can draw in this format. So think it, if I have taken this one, so this is called y equal to x. Okay, now this line and parabola both are intersecting at two different points. One is at the origin, need not to think more 0, 0. Another one is this point of intersection is there, assume that A, and it is not so difficult to find out because of x and y both are same. Okay. When you substitute it, that is goes to, both are equal here. You substitute y equal to x. This is comes, x is equal to 4x minus of x square, or x square minus of 4, that is goes to 3x is equal to 0. Minus x minus of 4x is goes to minus 3x, or x in bracket x minus of 3 equal to 0. This is comes 0 or 3. What you are solved, values are 100% correct or wrong, we can verify also. When x is equal to 0 you are taken, and if you are substituted in both the given equations, you should have the value of y should be the same. Now in this example, when x is 0, y equal to 0. When x is 0, y equal to 0. It means what? From both the equations, so we are getting the same answer is nothing but the given parabola and the line both are intersecting at one point, that is 0, 0. Now another point we have to check. When x is equal to 3, y is also 3. From this equation you can see that 4 into 3 is 12. 12 minus of 9 is 3. Means this point of intersection, what it is there, when x is 3, y is 3. Whenever that is corners, if you are evaluated, if you are having a doubt, so substitute it in the both the equations, you should have the same value for the other variable also. Okay. Now, in this example, after this step only, little bit take it care, because of randomly I cannot take it vertical or horizontal, because if I cover, that is goes to this term. Vertical, what happens? At a time I can cover line and this much. Suppose if you are taken the horizontal in this place, okay, otherwise this place we can start, no problem. Most probably this is parabola covers up to here, and this is covers line. Okay, this example also no problem, either you take it horizontal or you take it vertical. Now presently I have taken, so PQ is vertical, so take it as vertical. And anybody, if you are having a doubt, if I have taken the horizontal, is there any change in the answer? So you can confirm by taking that is horizontal. You should have the answer what I will get or what it is there in the textbook answer. Same answer you should have. Okay. So now that is goes to no symmetry property, nothing. So complete figure you have to take, integrate along the vertical strip, that is PQ, for which y varies from where to where? Geometrically P to Q. So P is a point on the line y equal to x, that is comes x2, and Q is a point lie on the parabola, which is directly given to us 4x minus of x square, because of both are expressed in terms of y. Y itself is expressed in terms of x, is nothing but more easy is vertical. So if you are taken the horizontal, what happens? From this equation, I should have what is the value x in terms of y, it is very difficult to you. Possible, but it is very difficult. Since both are expressed in terms of y, therefore the vertical is more easy. And x varies from left to right. Left is this term 0, right is this point of intersection, that is 3. So both you have to substitute in the given formula. Now all right, but area A equal to, you have taken double integration A into dA. This is equal to double integration vertical dy dx. So what the limits are there, that much we will write. 4x minus of x square 0 to 3. This is equal to 0 to 3 as it is y x to 4x minus of x square into dx. This is equal to 0 to 3 as it is 4x minus of x square, lower limit is x into dx. The last step is 0 to 3, 3x minus of x square into dx, 4x minus of x, and the integration 3x square by 2 minus of x cube divided by 3, limits of integration is 0 to 3. So this comes as 27 divided by 2, 27 divided by 3. Okay. So this is equal to 27 outside, 3 minus 2 divided by 6. LCM I have taken. Here it comes 27 divided by 6 or 9 divided by 2. 9 divided by 2. What the answer they have given, we'll see that. Parabola, answer is 9 divided by 2. Means that is goes to, don't remember the particular example, don't by heart it. Just you have to see that. So what the geometrically it is given to you, that is goes to, if standard symmetry is there, then that is goes to vertical you take, horizontal you take, it will not changes much. But non-symmetrical regions are given to you, little bit you have to think. So that is goes to, here if I have taken horizontal, what happens, you can check it here. This example, horizontal parabola, here comes P, here comes Q. So P is goes to y equal to 4x minus of x square. It is correct. From this equation, I should able to find out what is the value of x in terms of y. Means what? From here, I'll write it, it comes as complex. Or you can write it 4 minus of y with positive plus or minus under root comes. Since it is positive quadrant, you can take it as, so everything goes so little bit lengthy. After that, plus 2 you have to take this side, simplify. Okay. If you are taken the vertical, more easy, directly it is given to you y in terms of x from lower border also and upper border also. Easy to evaluate it. Okay. Now one example figure, just I'll show that the region. So afterwards you can evaluate it, that is the example, what they have given here. Find, that is goes to, find the area lying inside the circle. Yeah, word is there, circle, r equal to a into sine theta, and outside the cardioid, r equal to a in bracket 1 plus of cos theta. Just geometrically, that is, we'll see that what is the figure for that term. Okay. This is given to us. One is r equal to a in bracket sine theta 1 and r equal to a in bracket 1 plus of cos theta. This is the second one. Okay. Only geometry you see that. So after that we can think it about limits and everything. So this is the cardioid very clearly. It is a circle. There are so many circles.